Hey guys, it's your favorite teacher here again, ready to talk to you guys about the structure of the atom. We learned in class today that there are three subatomic particles. There's protons, there's neutrons, and there's electrons. And it's really important for us to know the difference between the two and what role they play within the atom. A proton is positively charged, it's in the nucleus, and it has mass. The neutron, no charge, it's also in the nucleus, and it's about the same mass as the proton. The electron is negatively charged outside the nucleus and has virtually no mass. So when we compare the mass of an electron to the mass of a proton or a neutron, it's basically minuscule. So we say it has no mass. Protons and neutrons and electrons can be distinguished, which means tell the difference between them by their mass, their charge, and location within the atom. So here's a pretty handy dandy chart if you want to write this down for your memory. So that you can have this with you whenever you need it. This table is an excellent way to remember the difference between the three. So the electron is negatively charged, so that's why you see an E with a negative. It has no mass, it's outside the nucleus, and its function within the atom is to control the charge. The electrons are what come and go fairly often in our atom, and we're going to talk more about that when we talk about bonding. The proton is positively charged. It has mass of 1 AMU. It's in the nucleus, and the proton's role is to define the atom. So, elements of carbon will always have 6 protons. Elements of oxygen will always have 8 protons. So it's like a fingerprint. It's the number of protons is unique to the different elements. The neutron is also in the nucleus. It has mass, but it has 0 charge. What it does, its function, is that it adds mass or subtracts mass from the atom. Everything scientists think about the nucleus and everything that we know about it is based on how these particles behave in relation to each other. The atoms of any given element always have the same number of protons. So if it has 8 protons, it will be oxygen. We call this the number of protons, we call this the atomic number. So the atomic number equals the number of protons in an atom of that element. You can use atomic numbers to refer to elements, kind of like a name or a symbol. So it's a unique identifying feature. So the name, the symbol, the name of the element, the number of protons, they're all synonyms because they're all unique to the different elements in the table. Atoms of different elements have different numbers of protons. So carbon has 6, nitrogen has 7, and oxygen has 8. So they're all different from each other. Each positive charge in an atom has to be balanced by a negative charge. And we've known this for a very long time. Even John Dalton and J.J. Thomson, who are some of the first scientists to come up with the idea of charge or like models of the atom, J.J. Thomson knew that an atom was neutral, so it had to be balanced by pluses and negatives. This means that the atomic number, which is the number of protons, is equal to the number of electrons. The mass number, because both protons and neutrons have mass, the sum of them is what we call the mass number. And when we're looking at the periodic table, we want to go with the mass number that's in whole number ratios. And we'll talk more about that in a little bit. But when you see the atomic number, just round it to the nearest whole number from the periodic table. Now, if we want to figure out, if we know the number of neutrons and we know the atomic number, we can subtract the mass number minus the atomic number to get the number of neutrons in our atom. Every atom of a given element does not have the same number of neutrons. So it will have the same number of protons. So carbon will always have 6 protons, but the number of neutrons can change in those different carbon atoms. So let's look at this challenge here. So here's the atomic number. So when we're looking at the symbol, the atomic number is usually the one on the top. And then we have the symbol of the atom. We have the name of the atom. And then we have the atomic mass of the atom. It's a pretty good idea for you to go and draw in this symbol because you are going to have to know where all of these things are for easy reference. The atomic number equals the number of protons or electrons in a neutral atom. The atomic mass equals the number of protons plus neutrons, basically the nucleus of the atom. So here when we're looking at O, we know that O is oxygen, so we can write in the name. The atomic number is always at the top, so the atomic number is 8. We know that the atomic mass, it's listed as 15.999. We're going to go ahead and round the atomic mass up to 16, and we'll talk more about that in a little bit. Just trust me that it's okay to round these. The number of protons is always the same as the atomic number, so the number of protons is 8. Now, to find the number of neutrons, we need to take the mass minus the protons. So 16 minus 8 equals 8. The number of electrons is always the same as the number of protons in a neutral atom. So if we have 8 protons, it means that we also have 8 electrons. Okay. For the next one, zinc has a capital Z and a little n. The atomic number is the one on top, so the atomic number is 30. The mass number, 65.39, needs to be rounded down to 65. The number of protons is also 30 because that's the atomic number. And because this is a neutral atom, I'm going to go ahead and skip down to the bottom because we know that the number of electrons and the number of protons is always the same. So then to find the number of neutrons, we take the mass minus the proton. So it's 65 minus 30 equals 35. At this point in time, I would like for you guys to pause the video and try this last one on your own, and then play the video again to see if you get it right. Okay, so now that you've tried it, let's go ahead and check our answers. This element is the element lithium. The atomic number is 3, which also means that this is the number of protons and it's the number of electrons. The atomic mass, we're going to round that up to 7. So 7 minus 3 equals 4. Okay. All right, well, I hope that you guys have enjoyed this video, and I will talk to you guys tomorrow in class. Have a good night.